Welcome to A-Star Science, part of our GCSE Must Know Physics series. Today we're going to talk about the topic of reflection versus refraction, a very important topic because we use this in everyday life. We also use the principles of reflection and refraction in science and technology. Very important things like satellite technology. Obviously, we use it in mirrors. Mirrors are used in lasers. So this is actually quite a very useful topic to understand, as well as it is a required practical that you need to know for your GCSE, how to carry it out. On the left, we have a plain mirror where we're going to talk about reflection. And on the right, we have a glass block where we're going to talk about refraction. A plain mirror is a flat mirror. And so we're going to use that to understand the principles of reflection. So let's first talk about what the law of reflection is. And then we're going to prove that using our practical setup. The law of reflection says that the angle of incidence, and we'll talk about what that is in a minute, is equal to the angle of reflection. So we're going to draw a light ray. We're going to use a straight line because light rays are always done with straight lines. Let's use the color red in this case. And the light ray is going to come in at some angle. Obviously, when it hits the mirror, the light ray then is going to also come out. So that's what you would see if you were doing a practical. I know it's a light ray because light rays have arrows and are straight. So we need to put an arrow to show the direction of the light ray. Now we talked about the angle of incidence and the angle of reflection. If we drew an imaginary line straight down, and I'm using a dotted line in this case, imaginary line straight down the middle of where the light ray comes out. This is called the normal. And it's done at a right angle to the surface. Okay, a right angle is 90 degrees. And if we now look, we can see that there's an angle here between the angle of incidence. This is the incident ray coming in. And this is the reflected ray going out. Going out. And that angle we call I is the angle of incidence. And this angle coming out, we're going to call R, is the angle of reflection. And we can see that they will be equal. So the law of reflection says the angle of incidence, which is here, is going to be equal to the angle of reflection. And we can prove that using a practical setup. Remember, the normal is an imaginary line drawn at a right angle to the surface of a mirror or to any other surface. Now let's look at the principle of refraction and what that means. The law of reflection is different than the law of refraction. The law of refraction says that the angle of incidence will bend towards the normal. When entering a denser medium. Now, what's a medium? A medium is any material, any matter that a light ray, in this case, or a wave, is passing through. So in this case, the glass block is a medium. And on the other side of the glass block, we have air, which is also a medium. So let's draw another light ray coming in to that surface. And let's see how it behaves. So here's our light ray going in, like that. Remember, when it hit the plane mirror, it reflected off. So now we need to draw the normal again. Remind yourself, what's the normal? The normal is a straight line, imaginary line, at 90 degrees to a surface. Now, what's going to happen to that light ray? Well, we said the angle of reflection says that the light ray, and we need to put an arrow on it. Let's make sure we're correct. Let's put an arrow to show that it's a light ray. That the light ray is going to bend towards the normal. So if I put another, let's see if I can get that right. Okay. Should be able to put it now. Like that. So it's bent towards the normal. And we can see that the angle of incidence, which is here, just like in the previous experiment, put a little I, the angle of incidence is going to be more than the angle of refraction, which we're going to put here. So the angle of incidence is less than the angle of refraction, which is here. So the law of refraction states that the angle of incidence will bend towards the normal when entering a denser medium. And so we can add to that law by stating that the angle of incidence will be greater than the angle of refraction. And you have to make sure you get your terms correct. Refraction is not reflection. So the angle of incidence will be greater than the angle of refraction. Let's create a bit of space for ourselves so we can continue our demonstration. So using that same line, that same light ray, let's add an arrow to it to make it accurate. What happens when it leaves that medium? Well, again, we need to draw a normal at where it's coming out. So I'm going to draw my imaginary line at a right angle to the surface. It's the right angle. And let's draw a line for when the light ray comes out. And that is going to bend back away from the normal. It's going to bend back away. Now, why does this happen? Well, the area here in the air is not as dense. It's less dense than the glass block, which is more dense. And because the light ray is coming in as an angle, it tends to slow down part of it first and ends up turning towards the normal. It turns that way. And when it goes back out into the less dense medium, it turns back out because it speeds up. So when a medium is more dense, the angle, the light ray, will turn towards the normal. And when it comes out, it will turn back away from the normal. Now, why is this important? Well, this is important because refraction can cause distortion. So, for example, if you had a person who was standing at the side of a lake, and here's our lake, and in that lake was a fish. Here's the fish. When they look at that fish, the fish would not be exactly where their eyes are telling them it is, because that light ray coming back towards them, the light ray entering the eyes, is going to bend as it exits the water, because water in this case is a very dense medium. So understanding how refraction affects light rays is important. It's going to be important if you're using things like telescopes, periscopes, anything where light ray can go in and out of medium. And remember that light rays are forms of electromagnetic waves. And so that means that these laws, refraction and reflection, also apply to all of the electromagnetic waves and wave functions in general.